Hello students, secondary to chemistry. Now are still in unit 2, modern periodic table, and our lesson today is the metallic and non-metallic property, also acidic and basic property. Now the first one, metallic and non-metallic property. If you have the periodic table generally as it is here, elements of group 1, group 2, 3, 4, 5 are not mentioned here, but 13, 14, 15 and so on till 18. Elements of group 1, group 2, group 13 are called metals. Elements of group 15, 16, 17 are non-metals. There is a group in between the metals and non-metals called metalloids. Metalloids contains boron, carbon, silicon, germanium, antimony. These elements are in blue here. These are metalloids. These metals are non-metals. These are metals. Okay. Metals are characterized by trying to lose electrons and become positively charged ions to be stable by losing the outer electrons. In the outer most energy level, there is 1 electron or 2 electrons or 3 electrons in the outer energy level, outer shell. While in the non-metals, there are 5 electrons, 6 electrons, 7 electrons in the outermost energy levels, and these metals are trying to gain electrons or tend to gain electrons to become negatively charged ions and complete their outermost energy level. In both cases, when these metals lose electrons and becoming positively charged, they become stable because they have the stable electronic structure of the inert gases. Also, the non-metals which tend to gain electrons will become negatively charged ions and also will become stable because they will be similar to the electronic configuration of also the noble gases. So the scientist Berzelius classified elements into 3 main groups: metals, non-metals, and metalloids. Metals on the left-hand side of the periodic table, non-metals on the right of the periodic table, metalloids in the middle of the periodic table. Metals characterized by having 1, 2, 3 or 1, 2 or 3 electrons in the outermost energy level, but non-metals contain 5, 6 or 7 electrons in the outermost energy level. The metals have brilliance, malleable, good conductors of electricity. All solids except mercury metals have great atomic radii. Metals have low ionization energy. Metals have low electron affinity. Metals have low electronegativity. The opposite of the metals are non-metals having the opposite properties as it is here. In between them there are metalloids. You have some properties of metals and some other properties of the non-metals. They have metallic appearance and have most of the properties of non-metals. They tend to lose electrons, tend to gain electrons, tend to form positive cations, positive ions, negative ions or anions. These are around the group 14. Okay. The metallic properties increases from right to left. From right to left, the metallic properties increases. This means that metallic properties here is great, and as you move from the left to the right, metallic properties appear. Okay, so in the same group, from up to down, the metallic properties increases from top to bottom, but in the same period, the metallic property decreases from the left to the right. Okay. Here is cesium, the most strong minerals. Fluorine is the most strong non-metals. Silicon is an example for metallite. Acidic and basic properties. You know that any metal can form an oxide. Metals form oxides such as sodium oxide, potassium oxide, manganese oxide, zinc oxide, many metals. Any metal, any element can combine with oxygen to form an oxide. If this metal is reacting with the oxygen, it will form metal oxide. If a non-metal reacts with oxygen, non-metal oxide will be formed. Okay. Metal oxides are called also alkali oxides. Why? Metal oxides, such as sodium oxide, react with water to form a base. So metal oxides are called basic oxides. On the other hand, non-metal oxides react with water to form an acid. So non-metal oxides are called acidic oxides. Why acidic oxides? Because the non-metal oxides react with water to give acids. Okay. Examples for these are sodium oxide, potassium oxide, magnesium oxide are metal oxides. Sulfur trioxide, carbon dioxide are examples for non-metal oxides. There is an oxide called amphoteric oxides. These amphoteric oxides do not react, dissolve in water, such as zinc oxide, aluminum oxide, antimony oxide. When an acidic oxide reacts, when a basic oxide such as sodium oxide react with water to form a base. Okay, sodium oxide react with water to form a base, but sulfur trioxide react with water to form an acid, and so this is called acidic oxide, but this is called basic oxide. Basic oxide means an oxide which reacts with water to give a base. This is another example, then this is another example. Also, basic oxide react, because it is a basic oxide, it reacts with the opposite, the acid, to form salt and water, while the acidic oxide react with the opposite, which is a base, to form salt and water. So sodium oxide reacts with HCl to form salt and water, sodium chloride and water. Magnesium oxide reacts with sulfuric acid to give sodium sulfate, which is a salt and water. Carbon dioxide reacts with sodium hydroxide to form sodium carbonate, which is a salt and water. Here is an amphoteric oxide. Amphoteric means it reacts with acids to form salt and water, and also it reacts with a base, as it is here. to form also salt and water. Zinc oxide and sulfuric acid react with each other to form zinc sulfate and water. Salt. Zinc sulfate is a salt. Zinc oxide react with sodium hydroxide, react to give sodium zincate Na2ZnO2, sodium zincate and water. Sodium zincate is a salt. If you have a compound MOH, M is an element, OH, oxygen and hydrogen. Any compound in the form of MOH may be an acid or a base. Okay? For example, MOH may dissociate to form MO minus plus H plus. In this case, this is an acid. MOH, if ionizes in the form of M plus and OH minus, this is a base. So MOH may be an acid or may be a base. How can you know if the substance ionizes as an acid or ionizes as a base? This depends on the nature of the element M. What is M? Okay. If M is a metal, metal means large atom. If the M is a metal, sodium, potassium, and so on, the attraction between the metal ion and the O minus minus is weak, but the attraction between O and H is large. So OH will be together and M will be alone. Okay? So if M is a metal, metal is characterized by having large radius, atomic radius. So the large atomic radius means this attraction is weak, but this attraction is greater. So OH will be together and M will be alone, and in this case the substance MOH will be ionized as M plus and OH minus. If the M is a non-metal, then metal means small atom or small radius. The small radius means the attraction between M plus and OH minus will be greater than the attraction between O minus and H plus. So MO will be together and H plus will be alone. So the substance ionizes as an acid. Okay. Here is some compounds of acids may contain oxygen or not. Some compounds which contain oxygen are called oxygenated acids. The strength of the oxygenated acid depends on the number of oxygen that are not combined with hydrogen. This hydrogen doesn't participate in the strength of the acid. This hydrogen. This oxygen has no value, but this oxygen, which is not bonded to hydrogen, as the number of oxygen atoms that are not linked to hydrogen increases, the strength of the acid increases. Okay? For example, say ortho-siliconic acid, it's H4SiO4. This is ortho-siliconic acid. 4 hydrogen atoms linked with 4 oxygen atoms in this way. There is no free oxygen here. So this acid is weak. Why? because there is no free oxygen. All oxygens are combined or linked to hydrogen. So this acid is very weak. Ortho phosphoric acid H3PO4, 3 hydrogen atoms are linked with 3 oxygen atoms in this way, but there is an atom of oxygen which is not linked to hydrogen. So this acid is stronger than this one. It is moderate, okay? Moderate, stronger than the weak. Sulfuric acid H2SO4, 2 hydrogen atoms are linked with 2 oxygen atoms in this way, but still there are 2 oxygen atoms here, 2 oxygen atoms not linked to hydrogen. So this acid is more stronger than this one. Why? This one contains 1 oxygen atom, but this one contains 2 free oxygen atoms. Okay, so this is stronger than this one. Here, perchloric acid HClO4, in which we can write H linked to 1 H with 1 oxygen here, but 3 oxygen atoms are not linked to hydrogen. So this is the most strong. Okay, and so this is the most strong acid, and now we arrive to the end of our lesson. Thank you.